listeners of statistics. This is a 201 and we'll be looking at the introduction from statistics, related statistics. We're going to look at the meaning of statistics, what statistics are about, and look at some branches of statistics, types of statistics, like its branches, and look at data presentations, and you can look at some illustrations and some examples. So what the statistics are about. Alright, statistics is simply an aspect of study or a field or discipline that is with the aspect of we're trying to collect data, gather data, make some analysis on them, some summarization, then collate data, interpret them, then have a well or suitable presentation to them so that people can easily understand. So it's an aspect of where it involves the process of collecting, gathering, analyzing, organizing, presenting them, giving an overview, and at the end summarizing the data. That the major purpose of that is just for us to be able to draw conclusions, and then for us to have a reasonable decision, or for us to reach a reasonable decision on the basis of that data. So in fact, it is more of like an analytical method, the general analytical method, whereby we are trying to provide some kind of draw some kind of influences, some kind of conclusion from the characteristics of the population through the observation we have made from the sample. So you get to know what I mean by population later on and what I mean by samples later on. We'll start looking at some terminologies in what the statistics. So do not forget that this is all about we're trying to collect data and try to lead us to the aspect of having information. So we're trying to draw a conclusion from the data, and then which enable from the conclusion you can be able to make some kind of decisions. So it helps to enhance our decision easily. So it is an important field that all other areas, and accountants or other field rather, so professionals actually have applied the knowledge of statistics. So with the knowledge, it's so easy for us to have an analysis of some data, and then we'll be able to reach a reasonable conclusion and decisions on the basis of the data we gathered and which we have made some analysis on. Alright, so the next aspect we'll be looking at is what are the various branches of statistics. So we have just two branches of statistics. So and they are descriptive statistics and influential statistics. So those are the two types. We have two basic basically they are basically two branches of statistics, and they include descriptive and influential statistics. So we can as well call the descriptive statistics. It can as well be called deductive statistics. It's also deductive. Initial is so deductive. You can call it deductive statistics. Deductive it can as well be called deductive statistic. So let me spell deductive upcoming. So it can be called deductive statistic. Alright, and the other aspect, which is influential statistics, can as well be called inductive statistics. It's inductive in nature. So we can look at each of the meaning. What is this descriptive statistics? So by its name, descriptive. So we are trying to describe some data. So describe the data, give where that has been collected and has been gathered. So descriptive statistics deals with the aspect of statistics. Descriptive statistics deals with the aspect of statistics that involves describing the data. So it involves collecting the data, then analyzing them, organizing them, summarizing the data, and presenting the data. So it's all include the whole aspect of data presentation, data gathering, collections, summarizing the data. They all fall under the descriptive statistics. So this descriptive statistics, we are trying to describe, deduce them, and through deductions, you can present data in a chart, in a bar chart. It can be presented in a chart, making use of through presentation. So this actually involve the aspect of collection, collecting the data collection, it as well involve summarization, summary, have a summary, give a summary to the data collected, give a summary to them, aspect of organizing them, organizing the data, as well as presenting the data in form of a bar chart, in histogram table, the whole force, other descriptive statistics. So one way of summarizing our data is through using some measure of central tendency, like mean, median, mode, the whole force there. Data presentations, that's visualizations, the drawing of bar charts, pie charts, histograms, what other graphs, most about presentation you can have. They all describe the data, so they are all falls under the word descriptive statistics. So the other aspect of statistics we have is the inferential, which is inductive in nature, and this does not in any way describe the data. It does not involve presentation whatsoever. It's basically this we're trying to draw conclusion. This is the aspect of statistics, but we can draw conclusions from. So it enables us to draw conclusion. Using the conclusion, so we try to draw influences. It enables us to draw influences. On the population through the samples that are being collected from the population. So with the future statistic, we'll be able to draw some kind of conclusion from the sample. So on the sample collected, and from there we can be able to describe, be able to explain the population well. So through our conclusion, the data can be enhanced. So this differential, we can draw influences from the collected sample that has been worked on, and then that will help us to explain the population in general. So it's an aspect of statistics that this is with trying to draw conclusions from the available data or sample that has been used, and it's actually inductive in nature. So it enables us to draw generalizations from the sample. So we can then, this is what we have on the sample, so we have worked on it, we have used the right hypothesis, and from there, when hypothesis is being raised, from there we can easily work on the hypothesis and see whether it is true or false. Once it's been true, we can then move forward to acceptance, and once it's been accepted, generalization can be drawn on the samples, and more particular generalization is being drawn on the sample. Once it is a representative sample, then what happens? It actually represents that of the population. So we'll be able to explain to this aspect. Actually this is what we're trying to draw hypothesis on the population. We can move to another aspect now, so which is population as samples. What is populations? I've been talking about population this while. So what's population all about? Well, what is it all about? So population, it's generally is a collection of object of interest. It deals with the whole of objects or things that is to be studied. The whole of, just think of the whole of the existence of the whole of of a thing which is in the area of interest to study. So what you are what you intend to study, you study the whole of, or the collection of it is with populations. So if you really think, okay, I want to study for your students, maybe you have a study that actually involves your population in the word generality or the collection of all the students. So after the idea of population, the whole, the collection of all of the thing of interest is the population. So if it is a complete collection of individual item data under consideration in a statistical was a statistical study. So this is a better definition. It is a complete collection of individuals, items, or data under consideration in the statistical study. So populations matter a lot. So it's very important we should be able to identify our population. Okay, the study of oil baths. Just think of the study of oil baths. What are the characteristics? You want to have a study of oil bath, the characteristics that actually what exhibits all maybe your population, the collection of all the oil baths. So the issues about population is that it might be difficult to study the whole of the population because the population are so large. So population are not even finite, they are infinite in nature. So we can't, it is irrational or impossible to even have a study of all of it or the whole of it. So that would then bring us to the issues of sample. Yeah, because it's highly difficult, if not even impossible, to have the whole of a thing into study because the population are are so much difficult to have and put them into study, or maybe as a result of that sad, they are so infinite, so you can't have the whole of the collection. So it's to infinity, so it might be difficult. So that brings us to be trying to study the parts of the population and put that into study. So a sample is simply a part of a population in statistical studies. It is a subset of the population. So what the issues of a sample is that when you have to take a sample from the population, we must ensure that the sample should be a representative sample. Representative sample in the sense that whatever conclusions we are to make on the sample, that can easily be, be taken, or you should be able to represent the population. So all whatever characteristics the sample should exhibit, it should be able to represent that of the population. So a representative sample represents the population, and whatever is being referred from it, actually it's generally being referred to the whole of the population. So since it might be difficult in statistical studies to study the whole of the population, we need to talk about the sample. So sample is a subset of the population, and we said a good sample being taken should be a representative sample of the given population and from which it was drawn, and this enabling that conclusion about the population to be referred. So it is from the word sample, whatever conclusion we are to make will be on the population will be made directly from the sample, and if it is to be true, then the sample have to be a representative one. So that is just that. Now we're talking about sample, which means there's need to actually talk about this aspect here, the aspect of sample frame. Sample frame is an important aspect that needs to be talked about. Sample frame. So sample actually contains the basic details of all members of the population. So it contains all of the details. What aspect can we actually draw our sample from? So the details of everything is where we can easily work. That is our sample frame, where we can easily generate information about drawing the sampling. So an items or whatsoever that contain the details of the member of the sample or population is what we call sample frame. Just look at this trying to have a study on OAU students. So okay, so if you are to take a sample from OAU students, since it might be difficult to have a study on all of OAU students. So to enable you to actually generate the sample, to know what you are going to take, you need information, you need details about your student, and where do you think you can generate that from? Where you can generate it from is, you can have a list of all students, and that way, where you can get that from, you can get that from the portal, from the portal or from the portal that on OAU website, if they can make that available to you, or you can actually check the student list. So if you can register in student register, if that can be made available to you, so you can see information about the student, and from there you can actually student register, so you can really generate your sample from that. So student register is simply a sample frame, so whereby we can easily generate details about students from it. Also, another aspect of sample frame is maybe you have a complaint in which you want to have a study on, so and the employees are your populations, the employee of the company. And how can you usually generate such sample? So you need a sample frame, and what we give you basic informations, basic details about the member of the populations, and they can easily get that. You can even request for the employee registrar. You can ask for their payroll. Maybe you want to talk about their salary scale. So you want to have a study about the employee salary scale. You talk about their payroll. That will give the information about each employee. You can talk about, or you talk about the employee registrar, employee register or lists. So which can give you the basic information about the private member, and that will enable you to easily draw your sample. Alright, so all of these are simply they are simply our sample frame. So I think you understand that better. So let's move to the next aspect. Okay, so employee registrar. So the next aspect now is we can look at why is it that in every study, sample is always preferred over populations. So why do we take samples to be more preferable to the population? Yeah, and it's very, very important. We know that with taking sample is more okay, more preferred to we taking the population. Why? Number one, the first reason is that sample is less expensive, because we are going to use in generate sample, or having a sample, taking a sample in preparation to study. It's less expensive or less cost compared you having a study all over the population. Samples less cost, sample saves times. Yeah, it saves a lot of times when compared with we having a study all over the populations. Yeah. Or also, it's enables the researcher to really manage its study, or it's make it to be manageable. Is it even manageable compared to you having to study all of the population? So these are the reasons why we think sample is more preferable, or the reasons why it is over the population. So it's better to take a sample because it's less cost, it saves time, and the researcher can easily manage it compared to with the share taking the whole of the population. The next aspect. Now the next aspect now we'll be taking is the ability of the statistical terms. So the first aspect we have is the aspect of parameters. So what is parameter? It's simply the characteristics of the population. So it summarizes the aspect of the population as a whole. So it's more of like an estimate of the populations. It helps to explain, represents or how can I, it summarizes, it's a summarized aspect of the population as well. So it gives an estimate about the population. So it's an estimate on the population. So it represents an estimate of the population. So parameter just like population mean, you know, it's where that is, if we should find the mean of all of the population, this will give the symbol we use in representing that, and it's not even called symbol, it's parameter. So this is the parameter. So whenever you add the word parameter, so it's an estimate of the population. So it shows that okay, this thing is being estimated from the population. So this is population's variance, this is population standard deviation, and this is a population proportion. So you get to understand them very well later on how to actually work on them. So whenever you see this parameter here, so this is for population mean, this is population mean, yeah, I've said the mean of the population mean. P represent population. Let me shorten that because of time. Population mean. This is population variance. And this is population standard deviation. Deviation. I think you understand that. I'm trying to write deviation. I think you get that this is deviation. Alright, so this is proportion, population proportion. So what gives summary on the population is simply what we call parameter. So what gives summary on the sample is our statistics. So this is statistics. So I tend to write statistic here. So what gives summary on the words on the, this is supposed to be statistics, a big error. So statistics actually gives so don't forget statistics. So statistic so this is statistics. Statistics is the number computed from the sample. It gives an estimate of the sample. So it summarizes the aspect of the work of the sample. So that is statistics. So alright, so statistics include the sample mean. This is sample mean. Don't forget, it includes the sample mean. So it includes sample variance. Sample variance. Sample standard deviation. Standard then we call it SD, standard deviation, SD, and sample proportion, sample proportion. So can you see? So each of them has our estimate. So if I should just write this, it means this mean here, this is mean, this is the mean of the sample, and this is the mean of the population. This represents the mean, this variance of the worth of the population. This represents the variance of the mean of the sample. This is the variance of the worth. The standard deviation of the worth of the population, standard deviation of the sample, population proportion, sample proportion. So they represent the what the estimates. Okay, so you can just note parameter. The term parameter is the population, as statistics is to sample. This is error, not statistics. Statistic. S is not there, please. So statistics is what we just explained. Statistics deals with we're trying to collect, analyze, gather data. Statistic is an estimate of the sample, so S should not be there. Note that this because of your tests or exams. So population parameter is population and statistics is to sample. Alright, so let's look at other terms, discrete and continuous variables. What's the discrete variables? Discrete variables is any values or variable that assumes a fixed value within an interval of number or within an interval of value. So assume a fixed value. So within 1 and 3 we can only have a discrete value, so which is 2. So let me just say within 1 and 2 there is just an interval of 1 there, so the discrete variable there is 1. So any number within an interval of value that is having its fixed value, it's a discrete variable. So 1, 2, 3, 4, 5 are discrete variables. So they are for a continuous variable, any value it can assume any value within an interval of number. Within an interval of 1 and 2, a discrete there is just 1. So there is no much value you can have. So it's just a fixed number of 1. But yeah, within 1 and 3, for a discrete number, the number between them is just 2. 1, so it's just a gap of 2. So within 1 and 2, the gap there is just 1. So fixed value. So if it's to be a continuous variable, the gap between 1 and 2 are, we have many numbers there. We have 1.1, so it can assume any value within an interval of number. We have 1.2, it can assume 1.2, it can assume 1.3. In fact, it can assume 1.45, 1.46 as a number. So that is within an interval of number. Actually, a continuous variable assumes many values, any given value there. So that is the aspect of continuous and discrete variables. So a quantitative data and qualitative data. For a quantitative data, we have data that they are numerical in nature. So they are recent numerical measurement. They can be measured. So they are within the countable range. That is for the aspect of quantitative data. And for the aspect of qualitative data, they are not numerical in natures. They cannot be quantified, and the issue is that they cannot adequately represent them with numbers. They are actually more of labels. They are categorical data because we don't call them categorical. So for qualitative data, we call them what? Why they call? We call them categorical data. They are categorical. Don't mind my handwriting. I'm sorry. So we call them categorical data. Categorical data. Yeah, categorical data. So we call them categorical data. So they are called categorical data. So then you understand this aspect of listen. Now let's move to the aspect of data presentation, data classification and presentation. So the issue is that data can easily be classified according to geographical locations, according to quality, quantity, and so on and so that. But you know that there is no way for data to be meaningful. It has to be in one way or the other be classified and presented in a meaningful form. So in order to have an idea from the raw data, so it's necessary that the work is being carried on in data. So that actually be the use of we having to classify data and present them. So data can actually be presented in a table, in a chart, in a diagram. So we are still going to talk about that. We are going to have data presentation in a pie chart, in an histogram, and other areas too. So that actually gives us more information. So we can actually classify data according to geographic location, quality, quantity, and time. So now let's talk about tabular data presentation. Data are mostly presented in a table. So and you know what table is? Table is just an inheritance operator in rows and columns. So if data are being arranged in a table in form of rows and columns, so we that has to be tables. So the arrangement of numbers of data in form of rows and columns are called tables. So tables are very important to provide useful information to us if we are able to work to present data in a table. Alright, now table can be in any form. It can be a reference table, it can be a working table, we can have a summary table. A reference table actually give us serve as reference to which you can actually draw other table from. So they provide large quantity of information whereby other table can easily be drawn from. So we also have a working table. A working table is just a table that we are expected to actually worked on. So whereby we can easily carry out some activities on. That is the aspect of working table. So summary table gives summaries or summarize some aspect of table. So it's been taken from the reference table. So we can actually, since a reference table might be too large, so we can actually take some part of the reference table and give it to be a summary table, and from there it can be a working table by it's being in use. Alright, so now let's move to frequency distribution. So data, as I've said, are represented the word in the table, so we can actually have a distribution in order to present our data in. So frequency distribution have been presented in a table. So using some aspects of frequency, so we can frequency actually shows the number of time or data actually occurred. So we can have data can be grouped or groups. Group data actually involve categorizing the data into classes. While on group data, we don't need to classify them into classes. So let's take an example of a group data. So for group data, we have this, and when you have the height of students, so these are the classes here. So students are formed between the height of 60 and 62 are 5. Students are formed between the height of 63 and 65 are 18. Students between the height of 66 and 68 are 52. Number of students within the height of 69 to 71 are 77. Students within the height of 72 and 74 are 8. So this is a very good example of a group frequency distribution. So students are being distributed according to that. Alright, so this year also we have score and their frequency. Number of people that score 4 are 12. Those that score 5 are 6. Those that score 6 are 8. Those that scored 7 are 14. Those that scored 8 are 5. Those that scored 9 are 2. So as I have said, this is more of a group data, and this here is what it's more of what on group data. Data are not grouped, they stand on their own, and here they are grouped together. So I think you understand what frequency distribution is all about now. So let's move on and move to another aspect. Let's look at those terminologies that relate to group data. So the first terminology, we have class interval. The symbols here are actually what we call class interval. So 1 to 10, 11 to 20, and so on. They indicate some kind of range of value. So they are class interval generally. So the symbol generally, when you have those eyes, 62 to 64, the symbol 62 to 64 is our class interval. So here when we have 11 to 10, that's the class interval. The symbol itself is class interval. Now class limits. Alright, so each of the symbols, we have two, just like the example here when we have 1 to 10 as a class interval, 11 to 20 as another class interval. We have two numbers there. Each of these numbers are called limits. So the first number, the lower number, is the lower limit, and the higher one is the upper limit. So in the interval, class interval of 1 to 10, 1 is the lower limit, while 10 is the upper limit. Alright, so that's the aspect of class limits. Now within a limit, actually it's possible that we might have a range of values that are very close to each of these limits, within 1, you can consider numbers that are very close to it. Those numbers that fall between 0.5 can also be considered as a boundary. So we can make that limit, this lower limit, to start from 0.5. So I will take away 0.5 from 1 from the lower limit, and also we can actually move that upper limit forward a little bit by 0.5, and also we consider values that fall between 10.5. So to get your, so this is our, this what we have here is what we call class boundary of this particular interval. So this is the class boundary of this particular interval. This is the class boundary here. So this is the class boundary. This we have here is the class boundary of this particular class interval. So you take away 0.5 of your lower limit in any class interval and add 0.5 to it, to the upper class limit here of any interval. So let me indicate that for you. So this is the lower limit here. Subtract, let me write that. Subtract 0.5 from it. Subtract 0.5, and here you are to add 0. You have to add 0.5 to it. I think that is okay for you. Alright, so next aspect here is what we call class. I need to erase this. Let me erase that so you can see it clearly. Alright, the next aspect now is the aspect of let's talk about class size and class width. So your class size is the difference between the class intervals. It's as simple as that. Between the upper, so between the class limit, rather class boundary rather. So the difference between the class upper class boundary and lower class boundary. So in this class, the class size here in our class limit of 1 to 10 will be 10.5 minus 0.5. So here in this place here, if we were to find our class size, our class size here will be the difference between the upper class boundary and our upper class boundary here in this class is 20.5. So minus the lower class boundary is, that will be 10.5. Subtract 0.5 from that will be 10.5. So the difference there, and difference that will be equals to 10. So the class size here in this class also is 10. So I think that is well understood. So other aspect now is class mark. Class mark is the sum of the word of the class interval, and we divide it by 2. Half of the sum of the class interval. So it's what the class midpoint. So we just sum the class interval and divide by 2. So as explained here, it said that it is the midpoint of the class interval, and is obtained by adding the lower and upper class limits and dividing by 2. Yeah, alright. So you sum your class limits together and divide by 2. So it's class mark for the class interval 1 to 10 is 5.5. That is, we sum 1 plus 10 together and divide by 2. That gives 5.5. Alright, thank you.
So let's take a look at how to create a frequency distribution table. So look at an example we have. The following distribution is the marks of 50 students out of 50 marks in SSC 201 test. So we have the marks here, they are 50 in number. So we construct a frequency distribution using the class intervals and also determine the class boundary and class size. So let's quickly do that. And let's quickly do that. It's very easy. So we have this. We have them here. These are the scores. So these are the intervals. So just create an interval. That is very easy. from 1 to 5, 6 to 10, according to the question, 11 to 15. So we have been given the class interval already. So now let's carry out the tasks. So here we have one, just be putting one stroke. So now, okay, 9 falls where we have 9 falls under 6 to 10. So just use this to represent that. So we have 36 falls here, so high. So we have 15 falls where 15 falls here, we have high. So we have 21 falls there. So we have 48 falls under this last. So next we have 28 falls under this last. So next we have 42 falls under this last. So next we have 7 is under this last. 7 is under this last. So we have 9 is under this last here, the same class. So that makes 3. So we have 14 is under this last here. So 14 is here. So it makes 2. So we have 31 here. 31 falls in this last here. So we have 43 is here. It's in this last. 43 is here. So we have 14 is in this last here. So we have 27 is in this last. So we have 33 is in this class here. So we have 1 is in this class. We have 1 again, that's in class. 31 is here. 16 here. 16 is here. So we have 18 is in that same class. So now 45 is here. Now we have 38 is here. 38 is in this class here. So we have 8 is in this class. So we have 26 is in this class here. We have 13 is here. So yeah, we have 27 next. 27 is here. 27 is in this class here. We have 40 is here. 40 is here. We have 36 is in the same class. So we have 41 is here. We have 8. That makes a bundle. So that makes a bundle. So we'll put a stroke. We need to strike a stroke downwards. Oh my god. So strike through. Okay. So that makes a bundle. Right. So that makes 5. Alright, so next. So that is, we've done 8. So now is 36 is here. 36 makes it 5 also. That makes 5 also. So we just did 8, so 36 now. 36. So that makes a bundle also. So we strike 2. let's do also strike through. So 41, that makes the boundary also, so we strike through. Sorry, 37, 36, 37. Okay, we did 36 now, 37 we are here. So 37, okay, let's stop the strike through. So we need to stop it. Okay, so 37, 26, so that makes the boundary here. 26, strike through, that makes the boundary. Yeah, we're going to close it now. Okay, so we have 20, that is 14 now. 14 here, that makes the boundary too. That makes the boundary with 14. So strike through, please. So 14 and 26. And we need to close it. So close it. Okay. So we are done with 14. Now 26. 26 here. So we have that. So again 26. Now 14. 14, we have 14 is here. We have that. And we have been able to close that coin out loud. Okay, because of time. Let's also do that. We know that. Okay, we have another strike entry. So 14. We have 14. Then 31. 31 falls here. 31 falls here. So we have 18. 18 is here. So we have 17. 17 is that same place. We have 4. 4 is here. We have 26. 26 is here. So we have 4. 4 is here. So we have 36. 36 is here. We have 43. It is here. Okay, that makes it boundary. That makes it boundary. Stop that. So we have 43 has been done. We have 19 is here. That makes it bounded too. Seriously, it's not easy. Alright, so we need to close that now. Just learn how to create the process of creating. That's what I just want to illustrate to you, so you'll be doing the rest yourself later on. So we have 2. So we need to strike through. Alright, so strike through. Alright, so we need to strike through now. So alright, so we have 40. 40 is here. 32. 32 is here. That makes 5 also. Imagine. Okay. Alright, so we have 15. 15 is here. So we have 28. and then 28 is there. So let's count. This is 5, this is as well 5, this is 7, this is 5, this is 1, this is 8, this is 5, this is 8, 5, 1. So we need to sum and see if we are right. Are we right? It must be 50. If it is not 50, that means we will not be able to do it well. So 50, we are 100% right. So class boundary. So if we do not forget, our class boundary is, we separating 0.5 from here, from the class limit, lower class limit here. So that will be 0.5 to 5.5, adding 5.5 to 5 here, that will give us that. And here we'll be taking 5.5, we'll take 0.5 from this and add the 0.5 to the upper limit, that will be 10.5 to 10.5. So here will be 10.5 to 15.5. I think that is so direct. So here will be 15.5, taking 0.5 from it and add the 0.5 to that, and that will be 20.5. Alright, so here will be 20.5 to 25.5. So and here is going to give us 25.5 to 30.5, and here will be 30.5 to 35.5, and here is 35.5 to 40.5, and here is 40.5 to 45.5, and here we have 45.5 to 50.5. Alright, so class mark, that will be equals to when we have the class limit plus upper class limit divided by 2. That will be that. So we have that. So that will be 6 plus 10 divided by 2, that will be 8. So this 11 plus 15 divided by 2, that will be 13. So this will be 18, this will be 23, this will be 28, this will be 33. You can confirm yourself. 38, 43, 48. So I think you have been able to create a class interval now. So easy. I think you'll be able to do your own. Alright, thank you very much. Take care. Alright, let's take a look on how to prepare frequency distributions and cumulative distribution, how to include this in our frequency distribution. Alright, cumulative distribution is simply the frequency of a particular class relative to the total frequency. So it is the frequency of this class, which is 5. It will be equal to the frequency of this class, which is 5, divided by the total frequency, which is 50. So we have that. So we can easily calculate that for the class now. If you have a 4, so you can auto-generate that. So that will give us, do not mind me, the total will surely give us 1. Do not mind my, I don't want to be doing it one by one, so I want it to be very fast. So the total will be 1. So you can as well put that in percentage by multiplying by 100. So how I got is 5 over 50. This is it here. 5 over 50, 7 over 50. 5 over 50 will give you relative frequency for each. Cumulative frequency is then just summing your frequency one after the other. Frequency of this is 5 cumulatively. So frequency of the next class is 5 plus the frequency of the earlier one 5. Summing, that will be 5, that will be 10, and so on. So this will be 17. Now 7 plus 10, 22. So we can actually automate that if you want. Well, so this will be 27, 23 now, So 31, 36, and then 44, 49, and then 50. So that's how to calculate the cumulative frequency. Alright, thank you very much. So before I leave this last, let me give you an example to prepare on. Try to provide the answer to this and send it to our WhatsApp group. Thank you. I'll be expressing that. Thanks so much. Take care of yourself.